Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the exciting release of Qwen2.5-1M, a groundbreaking advancement in large language models. It's a game changer.
Absolutely, I've been following this closely. The ability to handle 1 million tokens is mind-blowing. What are the key improvements over previous versions?
Well, primarily, we're talking about two open-source checkpoints, Qwen2.5-7B-instruct-1M and Qwen2.5-14B-instruct-1M. This is huge, because it's the first time we've seen open-source models with this kind of context length. And the performance gains are substantial.
Substantial is an understatement. The technical report highlights impressive results on long context tasks, right? They're significantly better than the 128K versions, especially beyond 64K tokens.
Exactly. They even outperform GPT-4o Mini on several benchmarks. But what's equally impressive is that they maintain performance on short text tasks, which is crucial. You don't want to sacrifice core functionality for long context capabilities.
That's a key point. So how did they achieve this massive context window? Is it just more data?
It's more complex than that. They used a progressive training approach, gradually increasing the context length. They also employed some clever techniques, like adjusted base frequency and dual chunk attention, DCA. DCA is particularly interesting. It remaps relative positions to smaller values, mitigating issues with rope in long context scenarios.
DCA sounds fascinating. It's addressing a fundamental limitation of the rope mechanism, right? The problem of unseen, large relative positional distances?
Precisely. And the results are compelling. Even models trained on only 32K tokens achieve near-perfect accuracy on 1M token passkey retrieval tasks thanks to DCA. It's almost magical.
Almost magical indeed. But what about inference speed? Processing 1M tokens must be computationally expensive.
That's where their enhanced inference framework comes in. It leverages sparse attention, specifically MI inference, with several key improvements. They integrated it with chunked prefill to reduce memory usage, refined sparsification for long sequences, and added other optimizations. The result? A 3.2x to 6.7x speedup in prefill.
Wow, that's a significant improvement. So it's not just about the model. It's the entire ecosystem they've built around it.
Exactly. They've also provided detailed instructions for local deployment, considering VRAM requirements and offering options for interaction via curl or Python. They even suggest using FP8 quantization to reduce memory usage further.
This is incredibly comprehensive. It's clear they've thought through every aspect, from training to deployment. What are their plans for the future?
They acknowledge there's still room for improvement, focusing on more efficient training methods, architectures, and inference techniques to make these models even more accessible and powerful. They're aiming for excellence in both short and long context tasks, which is a very ambitious but achievable goal.
It's exciting to see such rapid progress in the field. This Qwen2.5-1M release is a significant contribution to the open source community. Thanks for breaking it down for us.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll catch you next time with more exciting developments in the world of technology. Goodbye.
Bye-bye.